Most of this quiz is going to come from things you should have memorized from the notes. So hopefully you've already done that, because that's going to be everything you need to know for the quiz. So question 1 says, what organic reaction occurs when C12H22O11 and yeast react? So this C12H22O11, that's actually table sugar or sucrose, although you don't need to really know that, because what's really important is that you see yeast. And you'll either see yeast or the enzyme in yeast, zymase, and that's going to help you remember which reaction this is. And this reaction is fermentation. And you can justify that by saying you have yeast, because that's the thing you're going to notice and know that it's fermentation. Number 2 is referring back to the reaction in number 1, which was fermentation. They want to know what 2 products are formed in that reaction. And if you recall, fermentation is what happens when yeast digests the sugar and it produces alcohol, more specifically ethanol, and carbon dioxide. Not that I want you to think about beer, but that's essentially what happens when beer is made. It makes the alcohol, or ethanol, and the bubbles in the beer are CO2. Question 3, what organic reaction occurs when propylmethanoate and KOH react? Now this is an ester right here, and this is a strong base. And when you have a fat or an ester and a strong base, that is saponification. And you can say as your justification that you have an ester and a base. Looking for the product form in that reaction, there's actually 2 products. There's soap and there's glycerin, but what's really important is that soap typically, although glycerin can be used in a lot of applications, this would be soap. And if you ever forget, but you remember the reaction type, you can see soap at the very beginning of saponification. It's just rearranged. Question 5 asks, what organic reaction occurs when ethanoic acid and 3-heptanol react? So we have an organic acid and an alcohol, and if you haven't yet done this in lab, you will, but what you're making is an ester. If you remember from the notes, we said that an ester is a trapped acid, and this is the acid that gets trapped when you connect the heptanol on the other side. So you can justify this because you have an organic acid and an alcohol, and that's when you know you have an ester. Next question, what organic reaction occurs when iodine and pentane react? Really important that you realize that this is an alkane, because there's 2 reactions that look really similar. If this had said pentene, it would have been addition, but since it's pentane, it's going to be substitution. And you can justify that because we have a halogen and an alkane. And it's substitution because in order to put the halogen onto the hydrocarbon, you would have to remove hydrogens to do that. So that's why it's substitution. Just like when, I have a substitute teacher, there's someone in place of me. So you've had to remove me from the classroom and put in the substitute. And that's essentially what happens when you add a halogen to an alkane. You have to pull off the hydrogen. Now they're looking for the products, and you can either do it with a name or the structural formula. I find it easier to use the structural formula, so we're going to draw a pentane, but instead of putting all hydrogens on there, I'm going to put at least 1 iodine. I'm going to put it down here just because that's easier. But in order to put that iodine on there, I had to take off a hydrogen. And iodine doesn't exist as just I, it exists as I2. So I'm going to have a hydrogen that I pulled off, and the iodine are going to actually make a compound. So it's going to make HI. Next question, what organic reaction occurs when oxygen and methane react? Oxygen's the really important thing here. We learned in the notes that whenever you have oxygen and some organic compound, it's going to be combustion. And I'm just going to put oxygen and an organic molecule. And that will be a good justification for me determining that that's combustion. Now they want to know the products formed from this reaction. I always think of my furnace. Whenever I have my furnace combusting the natural gas that comes into the house, it's going to produce CO2, which I really, really, really want to go out my chimney, and also water. In fact, at one point I thought that my roof was leaking, but it was actually my chimney because all the water that's produced in this combustion reaction was actually coming through the chimney and into the ceiling of my living room and staining the ceiling. And it was just because I needed a new liner in my chimney. So when you burn something, you're not only producing CO2, but also water. Next question, what organic reaction occurs when many propenes react? You don't have to get so specific that you write down that it's an addition polymerization reaction. This is because of the double bonds. Whenever you have a double or a triple bond, it would be addition something. In this case, just addition polymerization. But you do need to say polymerization. And I recognize that that was polymerization because it said many. If you have a whole bunch of something, a whole bunch of the monomer, and you connect them together, then it must be polymerization. Next question, again, I see many. This time it says propanoic acids. And again, I'm going to justify it by saying many. For each of the next few questions, you're going to be figuring out the missing reactant or product. So looking at everything that you have first is going to help you figure out what kind of reaction it is and then what your products will look like. This first reaction, I'm given butane and then a blank. So I'm going to be looking for a reactant. And the products are CO2 and water. And the reaction we know that has some organic molecule and always produces CO2 and water is combustion. I'm not asking you to name the reaction type, but I am asking you to know what's missing, and that is oxygen. Combustion always involves oxygen. Next question, we have a hydrocarbon. It looks like we may have double or triple bonds in here. It's actually triple bonds. That's why we don't see any H's in here. And we have hydrogen, and we're supposed to come up with the product of that reaction. It might make it easier for you if you blow up the condensed structural formula to see what you're working with. So even though I'm writing this over here, it's not going to be one of the products. There's our carbon with the 3 hydrogens, a carbon, a carbon, a carbon with 2, and a carbon with 3. So I have 2 carbons there that are not satisfied with their number of bonds, and the only way I can make it satisfied and not go over on the other ones is by putting the triple bond right here. So probably what's happening with the hydrogen is that it's going to be added across this bond. When you do the reaction, you're going to get some product where this goes and eliminates one of the bonds in the triple bond. And some of your product will actually eliminate 2 of them, so you're going to end up with an alkane. So there's more than one correct answer to this. I'm going to draw the one where it only eliminates one of the bonds, and then I added one of the hydrogen, the H2s, from right here across that double bond, breaking that one bond and adding the hydrogen to either side. And then this one already had 3. Next one is also an addition reaction like that, a little more obvious since we can see the double bond without writing it out. So this double bond is going to be broken. What students tend to do is they don't add an iodine across both sides, which is exactly what's going to happen. I only have iodine to add to this. So when I broke that bond across here, both sides are going to get an iodine. I'm going to put it down here because I have more room. Don't put an H on one side and an I on the other side. I only have I to add to it. So when I break that double bond, you're going to get an I on both sides of that double bond. Next question, I have N. Whenever you see N, that means you have any number of ethanediols. So that's actually telling me that I'm doing a polymerization reaction. I don't really need you to come up with the exact products of this. I am okay with you telling me that you have ethanediol all linked together in a long series of chain, which you don't know that number of chains because it just says N. So in order to show that they're linked together, you're going to put it as a subscript. And now we know we have a polymerization product where ethanediol is all linked together. Next question, we have a blank and an alcohol, and I made ester and water. And that's going to happen in an esterification reaction. Ester, esterification. The other reactant in an esterification reaction is the organic acid. Remember, an ester is often called a trapped acid, and it's trapped by linking that alcohol to the other side. The last four questions are really here to kind of pull in what you learned in the first two sections of this unit and also to give you a little buffer in your grade. So this next one, pentane, we're just drawing an alkane, and it will have 5 carbons. So I'm just going to draw 5 carbons. They are all single bonded, and each of them needs a total of 4 bonds like so. Next one's a little trickier. We have methyl propanoate. So to remind yourself what propanoate is, you can't, or methyl propanoate is. Oh look, that happens to be this one. Of course, I've asked you to draw the structural formula, not this condensed structural formula. So you got kind of lucky. You could blow this up, but it's really important that you understand how to draw an ester. So I'm going to walk through that with you. The methyl is going to be kind of like a branch that is connected to the side with the oxygens that were, it was initially the acid part, which we see here has prop number of carbons. So we already have 1, 2, 3. And that is methyl propanoate. The methyl is over here kind of on its own, like it's its own little branch. And then the prop part is the part that has all the O's. So the part that gets the O8 is the part that gets the O's. That's why this is the 3 carbon side that has that double bonded oxygen. Next one, we have propanone, and the anone is a ketone, which looking here at our general formula, we have a carbon that has a double bonded oxygen, but what's important is that it's not on a terminal carbon. There's carbons on either side of this. So when we draw this, we have prop number of carbons, which is 3. And then that double bonded oxygen we said had to be on an internal carbon. So this is the only internal carbon. And that's why I didn't bother to call this 2-propanone, although you probably could. And then these guys each need enough bonds so that they have 4 apiece. Last one here, we have an ether. And a little reminder of what ethers are. Ethers have an oxygen linking 2 chains of carbons, which in the ether name sound like branches. So we're going to have a meth or 1 carbon branch connected to an eth or 2 carbon branch. And then just make sure the carbons all have enough bonds. Oxygen only has 2, so don't add any more to that. And we are done.